Howdy, my name's Amber Trueblood. I'm an associate research scientist at the Texas A&M Transportation Institute in the Crash Analytics Group. Today I'm going to be presenting findings from our TxDOT funded project identifying factors and trends to improve motorcycle safety in Texas. This presentation also is accompanied by a series of 3 fact sheets and 1 in-depth crash analysis report. These products were developed again by the Center for Transportation Safety at the Texas A&M Transportation Institute, in which I'm housed, and they can be downloaded from the Look, Learn, Live website. So before we get too far along today, let's go through the project objectives. First objective was to provide data comparing motorcycle crashes of all severities versus passenger car crashes in Texas. These data were downloaded from TxDOT's Crash Records Information System, commonly referred to as CRIS. The years for the analysis covered 2015 to 2020, which is the most recent year available. By comparing motorcycle crashes to passenger vehicle crashes, it helps to identify countermeasures that will help both types of crashes, while at the same time identifying countermeasures or trends that may be needed to address motorcycle crashes specifically. The second objective of this presentation or project looks at data comparing fatal motorcycle crashes in Texas versus the United States. The years for the analysis covered 2015 to 2019. The most recent year available for the Fatality Analysis Reporting System are commonly referred to as FARS data. These data are available from the National Highway Traffic Safety Administration's website. FARS data only captures fatal crashes, but since it covers the entire United States, we can make comparisons between Texas versus other states to get an idea of whether countermeasures that address motorcycle crashes need to be tailored to Texas specifically. In addition, it allows us to identify other states in which a countermeasure may be being used to address a problem Texas also encounters. Data from both sources are presented together throughout the presentation unless otherwise specified. A statistic referring only to fatalities is based on FARS data. Today's presentation is divided into 4 main sections: crash frequency, then demographics and operator characteristics, crash factors, and a focused analysis of rear-end crashes. The first section today is crash frequency. Let's go ahead and get started. So what does the data tell us about motorcycle crashes? Overall, each year, Texas experiences approximately 8,000 crashes involving motorcycles. This results in about 453 fatal motorcycle crashes annually. Each of these fatal crashes could have involved more than one motorcycle or a motorcycle operator as well as a passenger, meaning that multiple people in a crash could be injured. Each year there are approximately 2,100 motorcycle crashes each year that result in at least one injury. So let's go ahead and do a deeper dive into the data to understand the crashes we just described. Before we get too far on this chart or slide, let me define how crash severity is assigned. So in crash data, crash severity is assigned as the injury of greatest severity sustained by anyone involved in the crash. The graph shown on this slide displays the frequency of motorcycle crashes by year and their severity. By looking annually, we can identify temporal trends, which is important when we're trying to understand crashes on Texas roadways. Looking at this graph, we see the greatest proportion of motorcycle crashes are non-incapacitating, which is the gray bars shown on this figure, followed by our suspected serious, the yellow bars, then our possible injuries shown in the red bar, then non-injury crashes shown in the light blue, followed by fatalities shown in the dark blue bar. Now, when we start to look at temporal trends, we do see from 2017 to 2019 a decline in the number of fatal crashes as well as in the suspected serious injury crashes. However, of concern, from 2019 to 2020, the number of fatal crashes increased from 408 to 473, and the number of suspected serious injury crashes increased from 1,708 to 1,753. Therefore, the decreasing trend I just described, observed from at least 2017 to 2019, is starting to reverse course. So let's go ahead and put all the severity information that we just saw on the prior slide into perspective. 30% of our motorcycle crashes are fatal or suspected serious injury. How does that compare to passenger vehicle crashes? In the state of Texas, only 3% of passenger vehicle crashes were fatal or serious injury crashes. So that is an alarmingly different statistic, and it supports the need to better understand motorcycle crashes and identify countermeasures to keep our operators safe on Texas roadways. There are different ways of looking at crash data. We can examine raw counts and percentages by crash severity and year as we did on the prior slide and we'll do throughout the presentation. However, examining raw counts doesn't account for whether or not more people are riding motorcycles or whether people are riding motorcycles more often. To be able to make better comparisons over time or places, we can compute rates are the number of motorcycle crashes divided by the size of the driving population. Are the number of registered motorcycles, or an estimate of the amount of miles motorcycles travel on Texas roadways each year to better understand motorcycle crashes. The next 3 slides illustrate 3 different ways of computing crash rates. So the first slide shown here, we see the rate of motorcycle crashes per 100,000 driving population for each of the counties in Texas. Using the metric, the highest rate of motorcycle crashes are in the counties in dark blue, concentrated in far west Texas and central Texas, as well as other counties. So here you can see the dark blue here in West Texas, Central Texas, and then you see them spread throughout. Now this helps us understand where we're starting to see motorcycle crashes when we account for the driving population, which is important for us to understand. This slide displays a second type of crash rates. We're now looking at motorcycle crashes per 100,000 registered motorcycles by county in Texas. Our higher crash rates per 100,000 registered motorcycles are indicated by the darker blue colored counties on the map. Compared to the prior figure looking at driving population crash rates, many of the same counties are colored dark blue or have a high crash rate per number of registered motorcycles, as we saw when we looked at driving population. This next slide looks a little bit different, but I promise it's still a rate. It's just not mapped out by county. This slide illustrates motorcycle crash rates per vehicle miles traveled, or VMT. Using VMT is often a preferred way of computing rates since it takes into consideration an estimate of the number of miles actually spent on the roadway or the amount of exposure time at risk of getting into a crash. TTI developed a method for estimating motorcycle VMT in Texas on an annual basis using a variety of data sources, including population size, registration data, and household travel survey data. This table shows the rate of fatal crashes, suspected serious injury crashes, fatal and suspected serious injury crashes combined, and total crashes per VMT for motorcycles compared to the same rates per VMT for all vehicles. If we just look at the raw number of crashes, we find there are many more crashes involving vehicles that are not motorcycles than motorcycles each year in Texas. But if we examine the crash rates, we see that the rates of fatal and suspected serious injury crashes involving motorcycles is about 30 times higher than that of the crash rate per VMT overall. It is about 3 times as high if we compute the rate for across all crash severities. This next section examines demographic and operator characteristics and how they are distributed across motorcycle versus passenger vehicle crashes. Let's go ahead and take a look at who's involved in motorcycle crashes and passenger crashes and how those differ. So who's involved in crashes? Let's find out. We first looked at age as it's one of the strongest factors associated with high-risk driving behaviors. The 2 charts on this slide show us age for our motorcycle operators versus age of passenger car drivers. For motorcycle operators, the largest proportion were aged 25 to 44 years old, as shown on the bar chart here, accounting for 44% of our operators. The second largest age group was 45 to 59 years old, accounting for 25% of our operators. In comparison, the age distribution for our passenger car vehicle drivers was a little bit different. The largest proportion also was 25 to 44 years old, accounting for 39% of our drivers, but the next or second largest age group was 16 to 24 years old, accounting for 24% of our drivers. So we do start to see difference in the ages of drivers involved in crashes. So continuing to look at who's involved in crashes, we looked at gender distribution across our motorcycle and passenger drivers. By far, the majority of motorcycle operators involved in crashes are male at 95%. This is far higher than the proportion of male drivers of passenger vehicles, which account for 52%, which is much more similar to the proportion of males in the general population in Texas. Licensing status is also important when we're looking at crashes, as licensing shows us that the individual has the training and skill set necessary to operate the vehicle they're operating on Texas roadways. So with respect to licensing, we looked at different license status for our motorcycle operators and our passenger car drivers. Before we get too far, let's talk about the licensing required. Motorcycle operators are supposed to have a Class M endorsement, and passenger car drivers should have a Class C license. So with respect to licensing, 41% of our motorcycle operators did not have a valid motorcycle license or endorsement. Only 11% of our drivers of passenger vehicles did not have a valid Class C license for the class of vehicle they were driving. So following license status, we then looked at helmet use. Helmet use is also a predictor of crash severity for our motorcyclists. However, it's important to note that helmet use is not mandatory in Texas. Our analysis found that about half, or 1 in 2, of our motorcycle operators were wearing a helmet at the time of the crash. When we look at fatalities, we found that 39% of our operator fatalities were wearing a helmet in Texas. However, this is lower than the U.S. overall. For the nation, the percentage is about 49% who were wearing a helmet. The next or third section examines factors that may be associated with motorcycle crashes or that increase their severity, which is important for us to understand as we try to decrease the number of motorcycle crashes occurring on Texas roadways. So up first, we looked at environmental factors. We compared motorcycle crashes versus passenger car crashes. What we found is a majority of our motorcycle crashes occurred in clear weather, with 80% approximately occurring in that weather condition, versus 69% of our passenger car crashes occurring in clear weather. Up next, we looked at surface condition and found a majority of motorcycle crashes, with 94%, occur with dry surface conditions versus 86% of our passenger car crashes. These differences here may indicate when motorcyclists are out riding, which is typically in beautiful weather when we want to be out on the road, versus bad weather in which riding is not ideal. Next, we looked at lighting condition and found that 12% of motorcycle crashes occurred in dark, not lighted conditions versus 8% of our passenger car crashes. This could be indicative of where motorcyclists are riding, maybe on rural roads where the roads are more enjoyable to be on with less traffic and other attributes like curves and things that we want to ride on. Or it could also indicate a lighting issue or countermeasure that could be implemented to reduce motorcycle crashes on Texas roadways. So that is something we will examine further with some of our other statistics today. We then looked at number of vehicles for our motorcycle and passenger car crashes. It's important for us to understand number of vehicles to know if the crash was a single vehicle in which there was only one driver or operator involved, or multi-vehicle in which there were more than one driver or vehicle involved in the crash. So what we do see is a large proportion of motorcycle crashes are single vehicle crashes compared to our passenger car crashes, with 37% of our motorcycle crashes versus 10% of our passenger car crashes being single vehicle crashes. We then examined speed, as it's one of the biggest predictors of crash severity. What we found is 10% of all motorcycle crashes were speed related. However, the percentage increased to 17% for fatal and serious motorcycle crashes. When looking at our passenger car crashes, we see that speed played less of a role in our crashes, as listed. Only 3% of all passenger car crashes were speed related. However, this percentage more than doubled to 7% for our fatal and serious passenger car crashes. This indicates that speed also increases crash severity in our passenger car crashes, similar to what we saw on our motorcycle crashes. The next crash factor examined was distraction. Distraction is much lower in motorcycle crashes compared to passenger car crashes based on our analysis, 6% versus 10%. This may be a function of the fact that it is a lot harder to use a mobile device or do something else while riding compared to driving a car. So the next crash factor we looked at was impairment. Overall, a small percentage of our overall crashes were coded as involving drug impairment or alcohol impairment as shown. 1% of our motorcycle crashes involved drug impairment versus 0.1% of our passenger car crashes. When we look at alcohol impairment, which is measured by positive blood alcohol concentration, which is indicative of alcohol impairment, 3% of our motorcycle crashes involved a positive BAC versus 1% of our passenger car crashes. However, the percentage increases greatly for our fatal crashes, with the percentages being higher for our motorcycle crashes compared to passenger car crashes. For example, 12% of our fatal motorcycle crashes involved drug impairment and 24% involved a positive BAC. In comparison, our fatal passenger car crashes only involved 10% drug impairment and 17% positive BAC or alcohol impairment. How does Texas compare? If we look at every state in our FARS data, for the U.S. except Texas, 8% of our fatal motorcycle and passenger car crashes involved drug impairment. So we do see a difference there. So 12% in Texas and on average 8% for the rest of the U.S. However, the percentages of our positive BAC were comparable for Texas versus our other states. This slide shows us the top 5 motorcycle driver related factors. Today we've already talked about speed being an issue as well as distraction, so we won't focus on those top factors there. The other 2 factors that made the top 5 list were animals in the roadway, which contributed to 7% of crashes. In addition, changing lane when unsafe, which accounted for 5% of crashes. This slide shows us the top 5 passenger driver related factors, which we'll compare back to the motorcycle driver related factors we just summarized. Failure to control speed was also the top issue for passenger car crashes, accounting for 18.5% of the crashes. If you recall from our prior slide, failure to control speed accounted for 16.5% of our motorcycle driver related factors examined. Driver inattention was also a concern in our passenger driver related factors for crashes, accounting for 11.9%. If we look back at our motorcycle driver related factors, it only accounted for about 6.3%, which we've talked about that distraction distinction and possibility being that a motorcyclist is not able to do as much when they're operating a vehicle to become distracted as someone driving a passenger vehicle. Changing lane when unsafe was also a concern in our passenger crashes, accounting for 5%. This is very comparable to the 5.2% we saw in the motorcycle driver related factors on the slide before. 2 other concerns for passenger cars that were not on our prior list for our motorcycle driver related factors were fail to drive in a single lane and fail to yield the right of way while turning left. So we do start to see differences in those driver related factors and things that we may be able to do to address those factors on Texas roadways for our various crashes. Up next, we looked at roadway factors that could contribute to our crashes. First, we examined curves, which we found are a much larger concern for motorcycle crashes, with curves being a factor in 18% of motorcycle crashes, but only 7% of passenger car crashes. Can you think of a few reasons why there might be an increased risk of motorcycle crashes on a curve? So continuing to look at roadway factors, after looking at curves, we then looked at intersections. Intersections are a concern for our crashes because they are part of the roadway where vehicles are more likely to have to negotiate around each other. This is where we come together on the roadways. Over 1/3 of our motorcycle crashes occurred at an intersection or were intersection related. This proportion was even higher among passenger car crashes at 43%. Both of these statistics show us how important intersections are when we're looking at crashes. We will continue to look at some intersection statistics on the next slide. Continuing to look at intersections, we found a similar proportion of motorcycle crashes and passenger car crashes at intersections occur in dark conditions, with 40% of motorcycle and 44% of passenger car crashes. Both proportions are high, potentially due to decreased visibility under dark conditions that may actually be heightened for our motorcyclist, especially if the rider is not wearing high visibility gear. This last section presents findings for rear end crashes. We conducted a more intensive analysis of these crashes for 2019. Only 1 year of data was used because we had to analyze the crash narratives in other fields to determine whether or not the motorcycle rear-ended the other vehicle or the other vehicle rear-ended the motorcycle, which was very labor intensive, so we focused on 2019. We did not use 2020 data. As you know, there may be some wonkiness due to the COVID-19 pandemic that could bias the data, so we used 2019, which was the most recent year of data that we did not have any wonkiness, which was appropriate for this deep dive. Let's see what we found for rear end crashes. So in 2019, there were 907 motorcycles involved in rear end crashes, and the majority of these crashes, the motorcycle rear-ended the other vehicle. So 65% of our motorcycle operators rear-ended another vehicle in these crashes, compared to 35% in which the motorcycles were rear-ended. For our crashes in which the motorcycle rear-ended the other vehicle, we examined contributing factors. What we found, the 3 contributing factors that were most often assigned were failure to control speed at 54%, which we've discussed is a significant factor for our crashes, followed by driver inattention for 12% and 12% for followed too closely. This next slide examines injury severity, which we found varied slightly in our rear-end crashes. When the motorcycle rear-ended, the percent that sustained suspected serious injury was 21% versus 15% when the motorcycle was rear-ended by the other vehicle. Conversely, 18% of motorcycle operators sustained no injury when they rear-ended the other vehicle. However, this increased to 29% when the motorcycle operator was rear-ended by the other vehicle. Therefore, being rear-ended by another vehicle increased injury severity, but not fatality. So similar to the overall motorcycle crash findings we presented, we then looked at demographics for rear-end crashes to understand who's involved in these crashes. So with respect to age, the largest age group involved in rear-end crashes were in the 21 to 29 year age group at 30%, followed by those in the 30 to 39 age group range, accounting for about 23%. This is larger than the distribution of these ages in crashes overall, indicating an overrepresentation for these age groups. We then looked at gender, which found 65% of male operators in rear-end crashes rear-ended the other vehicle. In comparison, 58% of female operators in rear-end crashes rear-ended the other vehicle. So we do see a gender difference when we're looking at rear-ending vehicles. The rear-end analysis then looked at speed and intersection status, which I'm going to present now. As you saw in the main analysis, these factors are very important in understanding crashes. Let's go ahead and look at speed limit. The 2 pie charts shown display the distribution of posted speed limit by whether the motorcycle rear-ended the other vehicle or was rear-ended by the other vehicle. Rear-ending the other vehicle was associated with a higher proportion of posted speed limits of 70 miles per hour or higher, as shown on the pie charts. This last slide looks at intersection relationship and rear-end status. Rear-ending the other vehicle was associated with a lower proportion of being intersection related at 11% versus 19% if the motorcycle was rear-ended by the other vehicle. Overall, of interest, the vast majority of rear-end crashes were not intersection or intersection related. Thank you for listening to our presentation today. If you have any questions, please contact Eva Ship at e-ship@tti.tamu.edu.